Okay, so the next one is looking at delisted stocks, and that notebook is the second one here. And so what we're after is, as much as possible, avoiding survivorship bias. So we need to include stocks in our time period that have been delisted, so that, personally, when I was first experimenting with backtesting strategies, I made the mistake of using extreme survivorship bias, and it was at the time of the internet boom, and you get the most amazingly wonderful strategies that are completely worthless because the only stocks you're looking at are the very low percentage of ones that actually made it through. Okay, so we'll load the data again. And the first thing to know is that delisted stocks are shown in CSI with a quote or prime following them. So let's check for how many of these there are in this particular data set that we have. And there's the first 8 of those, and there are 72 delisted stocks. Now, we'll see how many actually occur both as listed and delisted. So, in fact, there are 17 of these. Now, the question is, why has this happened? If you were to just start CSI's unfair advantage program and just download the Russell 3000, this wouldn't happen. But over time, when it updates every day, so you basically set it up for automated updating, then there will be the old data when a stock is delisted and the new delisted symbol. And the first thing that you hope for, of course, is that all of the data in the delisted symbols is included in the data of the, sorry, all of the data in the file of the symbol that doesn't have the prime will be included in the delisted symbol, because it should have everything. So we're going to check all 17 of these that have both a delisted data and, as it were, active data. And what we're checking is just the number of rows for each, and then the difference in the rows. And first thing that comes up is a symbol like DNB, which is saying that the non-delisted symbol has 5 more entries than the delisted symbol. That's not fun. Same with MDG, MDXG, and SPB. And that's a significant number. So we need to look at these a little more closely. So we'll check for the number of dates for each symbol that are in the listed, but not in the unlisted. And this just creates a table comparing the two. Okay, so for AHL, so when there's a 0 in the not in unlisted, meaning that everything in AHL is in the AHL prime, but the delisted has 2 more values. So that's what we expect to have happen. But here DNB has 6 values that are not in the unlisted symbol, and the unlisted has 1 that's not in the old symbol. So you wonder how this might happen, and here's SPB, which is the most significant one. So 0 in this column is good, because we can just use the unlisted symbol, the one with the prime in it, and throw away the data in the other one. It's actually not clear how this came about, and it seems possibly to be an artifact of the way we were gathering the symbols, but part of it might be corrections that CSI made later. They're constantly massaging the data, and they do a very good job of that. And I imagine this is part of what's going on here. All right, so the standout case here is SPB, which has massive numbers. Now, we're just going to leave these 3 most, for the moment, there are not particularly many of them. So the first thing we want to do is see that the unadjusted close prices match across these. And there's only 17 of them. So all of the prices that are there that we do have do match, but then SPB has all of the extra ones. So if there's a 0 in the not in unlisted column, we can be reasonably confident that the corresponding listed file is entirely contained with the in the unlisted one. So we can just remove that file. However, what's going on with SPB? Well, what you see here is, and remember, what we need to look at is the unadjusted close, right? These numbers look quite different.
Yes, I think that's an important point. A lot of times, when we check this data, to find duplicates and outliers and whatnot, if you are using the adjusted version, you will see all kinds of outliers and you won't see duplicates. So for data integrity check, it's actually more useful to use the unadjusted version than the adjusted version. While when you backtest, you should use the adjusted version. So that's something that one insight that we come up from our effort in checking integrity.
Yes, exactly. I should have emphasized that it's the unadjusted close that we need to look at, because that is the thing that won't be changed when there's a dividend and so on. So all of the dates for SPB prime all lie in the dates for SPB, and the dates are common to both. So then you have to basically go and look and see, well, what happened with this company? And it recorded a split the spectrum bands, and the ratio of the last 2 unadjusted close is close to that split value. So although we haven't spent the time right now to go through and find out exactly what happened, it's clear that for using the data, we're going to have to ignore the delisted instrument. So we'll remove the data for the delisted one and keep SPB, and all the remaining non-quote appended symbols, which is what we expected to do, we'll leave those and retain the ones with the prime. So let's just do that removal here. And this is something that, here what I'm doing now is creating this file, and you will see this being used in the remaining notebooks that we'll be looking at today with this data. This file, R3K daily cleaned BZ, gets updated in sequence order by each of the notebooks. So it's important to go through them in the right order. And in fact, you won't see this file until right now.